Hey calculus class, let's look at this problem of finding the derivative of an exponential function, but this time we've got a quotient rule. So when we do dr dw, we need the quotient rule. So this is, call this u, call this v. The derivative of a quotient looks like this. All right, this is with respect to x, assuming u and v are both functions of x. Now we've got functions of w on top and bottom. So when we take the derivative with respect to w, same thing. We're just taking the derivative of the top, leaving the bottom alone, minus, take the top, take the derivative of the bottom, and then divide by the bottom squared. So when we do that, the derivative of the top, because that's exponential, it doesn't change. So it's 6e to the w times the bottom is 7w. Right, minus, now we leave the top alone, which is the same as taking its derivative, and take the derivative of the bottom. The derivative of the bottom would just be 7. And then we square the bottom. So the bottom squared would be 7w squared. All right, now notice that when we start to simplify this, notice we have a 6e to the w in both of these. We also have a 7 that's common to both of these. So up top, we could factor out a 7 times 6, which would be a 42e to the w. And that would leave a w, and then all of this got taken out, so a minus 1. And on the bottom, this would be a 7 times 7 is 49w squared. And then simplifying, 7 will go into 42 6 times. 7 will go into 49 7 times. So this ends up as 6e to the w minus 1, over 7w squared. All right, now you can leave it like that, or if you distribute it back through, you would have 6w e to the w minus 6e to the w over 7w squared. Now personally, if it were me, I would stop here, but either of these is acceptable. The reason I like this one is just because if I had to do another derivative of this, like a second derivative, both of these would have the quotient rule, obviously. This one would have a product rule within the quotient rule. This one would have the product rule within the derivative of difference inside the quotient rule. This will have a little bit more than this one. So I would stop here personally, but there's nothing wrong with this form. It's just kind of factoring out and then simplifying and then distributing back through. It kind of defeats the purpose of the factoring out that you did right there.